Hello everyone, welcome to this session. Our topic is extractions of the metals. So far in our previous video, we are discussing about the extraction of the sodium through the down cell. So today let's discuss the extraction of the iron from its ore. Here we're going to see the various procedures or yes, the technique that is used to extract the iron from its core. Now we have to know that this iron is just only the second to the aluminum as the most abundant metal in the Earth's crust. Its chief ores are the hematite and iron pure. This is impure iron 3 oxide, which it contains about 70% of the iron. Magnetite, that is all the magnetic iron ore, that is also the other chief ore where iron can be extracted. There's triiron tetroxide, which contains about 72.4% of the iron, and the sphatic iron ore. And last but not least, the iron 2 carbonate, that is the other chief ore for the extraction of the iron. It also occurs, this iron, it also occurs as the limonite and as the sulfide in iron pellets. Now, however, though abundant in the Earth's crust, the iron pellet is not used as the source of iron. So you have to note that also. Now, it is mainly used in, this pellet is mainly used in the production of the sulfuric acid. To extract iron 3 substances, you have to note that they have to be needed there. The first one, the iron ore. The chief ore is mainly the hematite, and it is mainly this iron 3 oxide that is mixed with sand. The second one is the limestone, which is mainly the calcium carbonate, and lastly the coke, which is made up from the ore. From the core, and is almost pure carbon. Now let's see the extraction of this iron in a blast furnace. So the extraction of iron is mainly carried out within the blast furnace. Now, before being introduced into the blast furnace, all forms of the iron ore must be converted to the oxides by roasting in air. We've seen this process of roasting in air when we are discussing the various steps for the extraction of the metal. So the roasting in air is there whereby you have to insert the ore in order just to this ore is exposed to intense oxygen just to obtain the oxides of the ores. So as you can see here, this iron carbonate, when it reacts with the oxygen, it leads to this iron 3 oxide plus carbon dioxide gas. Also, the iron sulfide plus this oxygen to lead to this iron 3 oxide plus the sulfur dioxide gas. Now, iron ore, coke, and the limestone are the ones that are mixed together to give a mixture called the charge. Now, the charge is the one that is introduced into the tower called the blast furnace, as you will see it in the figure coming on in the next slide. Now, at the bottom of the furnace, the hot air is the one that is blasted in through several pipes. Now, as well as at the bottom of the furnace serves to hold the molten iron and slag until this can be run off. Now, the charge is fed continuously from the top. So, as we said before, the charge is the one that contains these 3 main components: the iron ore, coke, and the limestone. So let's see the reactions that occur in the furnace. This is the blast furnace. Now, the first one, that at the bottom of the furnace, where the temperature is the highest, air attacks the coke to produce the carbon dioxide. As you can see, the carbon plus the oxygen gas leads to the carbon dioxide. While in the middle of the furnace, the rising up the carbon dioxide gas is reduced by the more coke, producing the carbon monoxide. As you can see, the carbon reacts with this carbon dioxide. So the carbon dioxide is reduced into more coke, as lead to the carbon monoxide. And the third, at the top of the furnace, the carbon monoxide, it reduces into the this carbon monoxide reduces the iron 3 oxide to the metal. So the carbon monoxide that was generated at the middle of the furnace, so it reacts with the iron ore, the iron 3 oxide. So the iron 3 oxide plus the carbon dioxide, carbon monoxide will result to the iron plus the carbon dioxide gas. So the molten iron trickles down the furnace and gathers at the bottom. So the collection of the iron is collected at the bottom. Now, periodically, this molten iron is tapped off and run into molds or the containers where it is allowed to cool in long bars of about 1 meter long and 10 centimeter in diameter. Now, at this stage is what is called the cast iron or the pig iron. A hot waste gases, the hot waste gases, mainly the nitrogen and the oxides of the carbon, they escape from the top of the furnace, and they are the ones that are used to heat incoming air. Now, this helps just to reduce the energy cost of the processes. So here's our blast furnace. As you can see, all the steps are described very well in this blast furnace. So there's all of these are just the components. There's iron ore, coke, and the limestone that are introduced as feed at the top here. Then all the processes that are carried out are just listed from the bottom here. The carbon reacts with the oxygen, leads to the carbon dioxide. Then at the middle stage, where here at the bottom is where there is high temperatures. So that's the resulting of the carbon dioxide, while at the middle is where this carbon dioxide reacts with the coke that leads to the carbon monoxide. And at the top, where it's like 1,000 degrees, the iron ore is the one that reacts with the carbon monoxide generated from the middle stage, leads to the iron as the product and the carbon dioxide gas. So the waste gases to heat up incoming air are the ones that are extracted in this place. I hope it's clear. So the structure of this blast furnace, there's brick lining here, hot air introduced, there's slag that is tapped out from here, and the iron tapped here. So that's how this blast furnace works. I hope it's clear. Moving on, let's see the action of the limestone. We said that this limestone is also the one of the component of the charge. Now, the limestone, which is introduced together with the ore, is first decomposed at high temperature from the the calcium oxide. As you can see, calcium carbonate is decomposed at high temperatures to just produce the calcium oxide or the carbon dioxide gas. Now, the main impurity in the iron ore is the sand made up of silicon dioxide. This reacts with the calcium oxide from the calcium silicate. As you can see, the reaction calcium oxide plus the silicon dioxide is to this calcium silicate. Now, the calcium silicate, which is in liquid state, falls to the bottom of the furnace. This liquid called the slag, because it is less dense than the molten iron, is tapped off separately. So the slag is the one that is used for byproduct, the one that is used in making roads, production of cement, etc., as production of the fertilizer. I hope it's clear, guys. Thank you for listening. We've discussed the extraction of the iron. We've seen the all the procedures that are carried out within the blast furnace. I hope it's clear. Thank you for listening, and see you in the next video.